Hi, so in this video we are going to be exploring the interpolation function, alright, from Python, and instead of using Google Colab we are going to be using the Spider package, alright, from the Anaconda. Okay, so hope you all have managed to install Anaconda, and from Anaconda, okay, the main page you can launch Spider, alright, and Spider is a built-in development environment, okay, which has all the packages and everything integrated, right, and it's a desktop environment, so you can use it without having to be worried about network issues. All right, so how can we go about looking at interpolation? So interpolation is basically how we can take some data points and try to connect these data points in a way that could maybe represent the information in a cleaner manner. All right, so let's start. So we're going to import numpy as np. All right, then import matplotlib dot pyplot as plt, and from scipy dot interpolate import interp1d. All right, so numpy is a numerical Python. All right, it's a package that contains a lot of mathematical tools to help us. All right, so we import numpy as np. Matplotlib, typo here, matplotlib.pyplot is a package for all the plotting requirements, and scipy is scientific Python. Again, there is some overlap, all right, between what numpy has and scipy has, but scipy has a bit more enhanced functions or APIs to help us with many other mathematical or scientific functions. All right, so from that library or that package, we import interp1d for interpolation. All right, now let's create some sample data points, and we will do this step by step so that we are able to understand, all right, what we are observing. So I'm going to create some point. Okay, so 0 to 5, y equals to np.array 0 1 4 1 0 3. All right, now what I'm going to do is, first I'm going to plot this data first. So I'm going to say plt.plot x y. All right, we're going to put circles. All right, the O represents circles for all the coordinate points, and I'm going to give this a label as the actual data points. All right, and let's give it a label. Okay, so this is the plot, plt.title. Let's give it a title as well. So linear versus cubic interpolation. Okay, so we are trying to observe the difference between linear and cubic interpolation. Okay, so plot dot label x label. So we're just going to label simply x and y. All right, y. Then we're also going to show the legend, and finally plot dot show. All right, so let's run this. Let me see, there's a typo there, label. All right, so this is what you get. Okay, so you can see that we're able to get all these data points, all right, on this xy axis. All right, now what we want to do is we want to be able to see how will it look like if I do linear interpolation or cubic interpolation. All right, so let's go ahead and do this. So the first thing we're going to do is we're going to call this function linear. Okay, so we're going to call a function called the interp1d. So we're going to do both linear and cubic. So interp1d. So I'm going to pass in my x and y values, and I'm going to say kind is linear. And I'm going to do the same thing, cubic inter1p. So x, y kind equals to cubic. Okay, so what does this interp1d do? It takes in the original xy data points that we have given, and it will try to interpolate this data, once using linear and the other using cubic. Alright, now in order to print out this new set of interpolated data, we're going to create a lot more x values, alright, and try to map them. Okay, so let's go and create x find equals to np dot linear space 0, 5, 100. And what we're going to do is we're going to create two new outputs, y linear, which is calling the linear interpolation with the x data, and the other one is y cubic. Okay, cubic interpolation of x find. Alright, so now let's go ahead, and so this is the original data, and what I'm going to do is I'm going to plot the linear first. Okay, so I'm going to say plt.plot, okay, x find with y linear. Okay, this time we're going to just use, alright, dot dash dash lines, alright, and the label will be linear. Alright, so let's run this. Okay, so there's a typo here, interp. Alright. Okay, so you can see that the linear interpolation basically just attempts to draw a straight line that connects all the dots together. Okay, that connects all the dots together. Now let's do the same thing now on the next step, which is the plotting with the x find and the y cubic. Okay, and this time we're going to use the dash line. Okay, and the label will be cubic. Alright, so you can see that with the cubic interpolation you can draw a smooth curve or smooth curves or lines to connect the dots, whereas with linear you are just talking about straight lines. Alright, so this gives you an idea, alright, how, alright, interpolation works. Alright, so with interpolation what you're trying to do is we're trying to connect all the dots together. Alright, and if you want straight lines, then we use linear. If you want a smoother connection between the lines, then we use cubic. Alright, so I hope that this gives you an idea how to use this interpolation, alright, in your code, alright, to connect up the dots and get a visualization of how the points are changing. Alright, thank you for watching. I'll see you in my next video. Bye.